Okay, the final topic is the Bonferroni adjustment. The Bonferroni adjustment. We just talked about type 1 errors, the fact that sometimes we reject the null when we should not have, and that is set at alpha. So if we have an alpha of 0.05, 5% of the time we reject the null when we should not have. The problem comes in when we do lots and lots of hypothesis tests. So let's say we do a 100 hypothesis test. Well, then 5% of the time we would be expecting to reject the null incorrectly. So these errors add up over time. And so whenever we do a lot of hypothesis tests, we could be falsely rejecting several hypotheses. So Mr. Bonferroni rightly saw this as a problem. So he said what we need to do is lower alpha, lower that type 1 error rate, and then we won't make so many mistakes. We won't so often reject the null when we should not have. And Mr. Bonferroni had a suggestion. He said, okay, we want a new lower alpha, and that new lower alpha is equal to the old one, let's say 0.05, divided by the number of hypothesis tests you're doing. So let's say you're comparing males and females on 100 different variables, height and weight and cholesterol, depression index, and so on. So you're doing 100 hypothesis tests, comparing males to females on 100 variables. Well, then your new alpha would be 0.0005. And then you would take those 100 p-values from those 100 hypothesis tests and compare each of them to 0.0005 and see which ones have a p-value less than or equal to 0.0005. And those are the ones that would be statistically significant. So there's an example on the new handout. Frank and Frida are doing research, comparing males and females on 10 different things, cholesterol, triglycerides, and so on. They sent their article into a journal, and all the p-values under 0.05 they claimed were significant. So cholesterol and triglycerides and insulin and glucose and estrogen and testosterone and ferritin, all those had p-values less than or equal to 0.05, and so they claimed all of those were statistically significant. So the journal replied saying you need to do a Bonferroni adjustment, and journals will do this. When you read a journal article, you should be seeing we use the Bonferroni adjustment when they're looking at lots of different variables. So they asked Frank and Frida to do a Bonferroni adjustment. So what is the new alpha for Frank and Frida? Well, the old one was 0.05. They were looking at 10 different variables. So Frank and Frida's new alpha is 0.005. Which of their variables are still statistically significant? In which cases do we still have a statistically significant difference between males and females? Well, we have to look for p-values that are less than or equal to 0.005. So that's cholesterol. That p-value is 0.005. And estrogen. That p-value is 0.0001. And testosterone. That p-value is 0.0001. All these p-values are less than or equal to 0.005. So those are the ones that are statistically significant. So when you're doing many hypothesis tests, listen to Mr. Bonferroni. Lower your alpha, lower your type 1 error rate, so not so many are statistically significant just by chance.